So the next thing that I want to talk about here is I want to talk about average speed and velocity. So we need to be careful how we talk about our words here. So let's define position before anything. So position which is what we call a scalar quantity, is the physical location of an object. From the origin. Displacement which is a vector quantity, is in objects change in position. So that means because it's a vector, we then go in and we symbolize it this way. So then if I look at the displacement, again, we use that symbol with an arrow like this, and then it has two pieces. It has this plus and minus sign, and then it has the difference between two positions here. And so what we're seeing here is that this guy is the, oops, let me be careful here. That plus and minus sign, this is the actual direction of the vector. And I think I'm going to change this color here. And then this piece here is the magnitude. So if I was to be just a little bit more careful how we do this, when we say the magnitude, it really is the absolute value of x2 minus x1. And so when we say the direction, it doesn't matter how we define what is positive or negative. We typically write positive and negative, or we could just say it could be right or left. A lot of textbooks tell you that every single time to the right is positive. Every single time left is negative. I strongly recommend that you don't do that. And here's an example why. Think about it. Let's say that you're driving from Cabrillo down to Santa Cruz. Is that the positive or is that the negative direction? It's neither. You don't assign a direction. You don't assign a positive or a negative. All you just say is that, and that, you just typically think of that as sort of like the positive direction. On the other hand, if you were coming from downtown Santa Cruz to Cabrillo, would you call that positive or negative? Neither. So don't get stuck on what textbooks tell you what the direction is. Directions are, or coordinate systems are your slaves. You want to make sure that you put them to work for you. So here's what we really say. You know what? I'm going to take this out. So the magnitude then tells us essentially how far did you move? And then the arrow tells you which way? That's what that tells us right here. So let's look at an example here just to give you a sense of what I'm talking about. So as an example, okay, this is just I'm just kind of making this up as I go along. So let's do this here. It takes 35 seconds to walk from, let's say, x equal to minus 12 meters to x equal to minus 47 meters. What is his velocity? Well, what we'll do here is that let's just set up a number line. If I set up a number line, let's say that this is 0 right here. And we'll say that that's our origin. Then what I'm going to do here is that every 2 squares, I'm going to make that 10 meter units. So that means that the distance between 2 squares is 10 meters. Now I'm going to set up a coordinate system. Now I could call that west, but it's common to come in here and just say that's, I'm going to call that negative, and I'm going to call that positive. So my direction is set that way. So if I look at how I scale this, this will be 10, 20, 30, 40, 50 meters. So where is Juan here? So what I imagine, I'm going to make Juan this little purple guy right here, right? He's standing right here. And Juan is located, according to the system, I'm going to say that he starts off at x1 equal to minus 12 meters. Now he's going to start to walk. And he's going to walk all the way to 47 meters. So if he stops at 47 meters, he's going to roughly stop right there. So then I'm going to come in here and I'm going to say that x2 is in minus 47 meters. So I can clearly see that his displacement is in this direction. He's changing position in the negative direction. So here we go. So now what I want to do here is I want to calculate his magnitude of displacement. So if I calculate the magnitude of the displacement, then I see here is that my displacement is really x2 minus x1. So if I look at this, then this tells me here that this is going to be minus 47 meters. Then it's going to be minus, and then he starts off at minus 12 meters. And so when I subtract that, you can see here is that it's going to be the absolute value of negative 35 meters. So what this really tells us here is that he walked a total distance of 35 35 meters. So now that I have the displacement, I can write my velocity vector. So this tells me then that the speed of Juan is then going to be, so this would also be the absolute value. That's how fast he's moving, is then going to be, it's going to be 35 meters in 35 seconds, which is 1.0 meters per second. That's his speed. So now I could then say that Juan's velocity is this vector that tells me that it's moving at 1 meter per second and it's moving in the left direction. That is his velocity vector right there. So the negative sign only tells us the direction that he's moving. So one of the things that I want to do here next is that I want to talk briefly about unit conversions, and then let's just look at some examples that go something like this here. So unit conversions are something that I assume that you are quite familiar with, and the PLC is really there to sort of check you to see if you understand unit conversions. I mean, there's lots of unit conversions. Like here's some common unit conversions. Like one of them, one of the important ones in this course is 1 inch is exactly 2.54 centimeters. In other words, I can replace this as either 2.54 centimeters equal to 1 inch, or I can also write this as 1 equals to 1 inch to 2.54 centimeters. So it's this key of rewriting things into one here. So there, for example, if I look at 1 hour, we know that 1 hour has 24 hours. We know that oops, I'm sorry, that's not really what I wanted to say. It has 60 minutes. And we know that 1 minute is the same as 60 seconds. So this tells me here is that I can convert hours into seconds by multiplying quantities by 1. And so in this case, what I'll do here is I want to convert hours into minutes. So then I could write this as 1 hour times, now if I take this quantity right here, and then I readjust this thing, I can rewrite this, and I want to put the hours in the denominator. So I can rewrite this as 1 hour into 60 minutes. So then if I multiply that by 1, this will then be 1 hour into 60 minutes. And right away, we can see here is that the hour cancel out. And so I am left with 60 minutes. But I can do the same process all over again by multiplying by 1. And if I use this conversion factor, where I then put my minute in the bottom to cancel, then if I bring this back in, I could then see that I can write this as 1 minute into 60 seconds, where I now have the minute canceling with the minute. And so then I get 60 times 60, which is then 3,600 seconds. So that means here that 1 hour is the same as 3,600 seconds. Now, that seems like, that should be fairly familiar here. So here we go. Let's look at some examples just to make sure that, that this is, you're well practiced on here. Let's convert. So the first thing I want to do here is that I want to, as an example, I want to convert, let's say I want to convert each of these units into proper metric units of meters and seconds. So here we go. So the first one I want to focus on is I'm going to say that I have 80 inches. So there's a couple of things that I'm going to expect you to know here. So this is a very important relationship right here. So I'm going to start from scratch, and here I go. So then I'm going to use this conversion, and I'm going to go all the way into meters. So here I go. So the first thing that I'm going to do is that I'm going to multiply by 1, and I'm going to convert into inches into centimeters. So then that means here that I'm going to take this and I'm going to manipulate it so that the inches are in the bottom. So this is going to be 1 inch is equal to 2.54 centimeters. Right away, I see that the inches cancel. Now, another thing that you should know here, which I did not list here, is that there are 100 centimeters in 1 meter. Okay, so this you have to know this value right here, that 100 centimeters is equal to 1 meter. This is an absolute must. So I'm going to multiply that by 1, and then I'm going to put centimeters in the bottom. So this should be 100 centimeters divided into 1 meter. So if I start to look at this thing, you could see here is that this centimeter and that centimeter cancel out. So now, if I look at this whole thing here, I am now multiplying everything at the top, which will be 80 times 2.54 times 1. And then I'm going to look at everything in the denominator, which will be 1 times 100. And the only unit left is a meter. So if I compute this, I'm going to get 0.20 meters. And this is the same as 80 inches. So I'm just stringing conversion factors together. let's look at this next one. This one is 66 feet per second, and I want to convert that into meters per second. So this is 66 feet per second. So in this case, I'm going to write this as 66, and then I'm going to write feet per second like this. So that means I have to convert feet into centimeters and then convert it into meters. So then again, I start multiplying my quantities by 1. So using the right conversion factor, I have to convert feet into inches. So I know that there are 12 inches in 1 foot. So then I'm going to write that this is 1 foot into 12 inches. So right away, I can see here is that feet and feet cancel. So now I have inches per second. Now, the next thing that I got to do here is that I got to convert inches into centimeters. So if I want to convert inches into centimeters, we already used that before. We saw that 1 inch was exactly equal to 2.54 centimeters. So inches is in the denominator now. And then I have 2.54 centimeters. So that inch and that inch cancel. So now my distance unit is in centimeters. So as we did before, we need to convert into meters. So if I convert into meters, just as we did above here, then I know that this should then be 100 centimeters into 1 meter. And so what I'm going to see here is that I could see that the centimeters cancels out with that centimeters. So then if I start multiplying everything through here, you could see here is in the numerator, I got 12 times 2.54 times 1. And the denominator, I'm going to have 1 times 1 times 100. And then I'll have units of meters per second. And so if I multiply that whole quantity, I'm going to get that this is 20 meters per second is the same as 66 feet per second. And then as the last one here, I'm going to look at 60 miles per hour, and I want to write that in terms of meters per second. So here we go. So what I'm seeing here is that I'm going to look at 60 miles per hour here. Now I'm going to have to look up how many miles are in meters, or we could do this multiple ways. So what I'm going to do here is that I did a search. Okay, so right here, I did an online search, and I found that 1.609 kilometers is equal to 1 mile. So that's what I'm going to use. So if I do that, I gotta adjust this thing so that my miles are in the denominator. So here I go. So in this case, I'm gonna have 1 mile in the denominator, and in the numerator, I'm gonna get 1.609 kilometers. But you should know this already, that 1 kilometer is the same as 1,000 meters. So then I'm going to convert that. So then I know that 1,000 meters is the same as 1 kilometer. So when I look at this thing, you could see that the kilometers cancel just as the miles cancel right there. So now I need to I got it into meters, but now I need to convert hours into seconds. We just did here that 1 hour is 3,600 seconds. So I'm going to use that. So if I convert, so look at hours, it's in the denominator. So I now need hours to be in the numerator. So then 1 hour is the same as 3,600 seconds. So if I look at this thing, you could see here that the hours here cancel with the hours there. So now I could now multiply everything together here. So this will be 60 times 1.609 times 1,000 times 1 divided into 1 times 3,600. And this will now give me units of meters per second, which gives me 30 meters per second is the same as 60 miles per hour. So let's look at this example right here. So let me see. So one of the questions here, it says that the inches to meters conversion is off by a factor of 10 inches to meters. I don't know where I converted inches to meters. I converted inches to centimeters. I don't think I converted any place like that. Oh, I see. In A, I might have a numerical number. Is that what it is? Is it 2.0? So let's see here. That's going to be 0.8 there. I don't think that, is that? I don't think this could be 2. I don't think A can be 2. And the reason why is that if you have 80 times 2.54 divided by 100, note that this then becomes 0.8 times 2.54. That is no, is that it does look like that's got to be 2. I think I stand corrected. So I'm going to say that this answer is not a correct answer, that this should be 2.0. Thanks for the heads up. I appreciate that. Okay, so that was an incorrect answer. Okay, let me grab this example here. And let's go over to here. So again, I'm going to try to make this distorted here to make it easier to read. So it says that the end of the Hubbard Glacier in Alaska advances at an average of 105 feet per year. What is the speed of the glacier in meters per second? Okay. Let's see if I don't screw up here. Okay, let's see if I don't screw up with my numbers here. And you should never trust me. Always keep me in check. So here we go. So I want to know the speed of the glacier in meters per second. So here we go. So I know that the speed of the glacier should be 105 feet per year. It's the year that's going to be an issue here, because that's a lot of conversions. But let me give you a hint of how I remember how many seconds are in a year. Okay. So here's a hint that I always think about. If I don't have to worry about the right answer or just get close, 1 year is approximately pi times 10 to the minus 7 seconds. Not minus, but 10 to the positive 7 seconds. And if I remember correctly, this guy is really 3.16 times 10 to the 7 seconds. So it's close to pi. A lot of the times on these calculations, if I don't have to worry too much about getting the right answer, I just go ahead and put in pi. So that's just something that's stuck in my head. So here we go. Let's start with that. So the first thing that I'm going to do here is that I'm going to convert feet. So feet then say that 1 foot is the same as 12 inches. Then I know that inches has to be 1 inch for every 2.54 centimeters. So if I now start to do the cancellation, I could see that the feet cancel, the inches cancel. So then the next one that I want to do here is that I want to go into meters. And if I go into meters, that tells me here that this is then going to be 100 centimeters is going to be to meters. So right away, I see here that I've converted all of my feet into meters now. So now I'm going to convert year into seconds here. So if I look at this thing, I'm then going to say that if I use this little trick that I have, look at my years. It's in the denominator. So I got to put this in the numerator. And then I'll use 3.16 times 10 to the 7 seconds. So if I multiply this all out, this should be 105 times 12 times 2.54. And then I get 1 times 1. And then I'm going to go 1 times 1 times 100 times 3.16 times 10 to the 7. And this now gives me meters per second. So if I get this right, the 2 sig figs, I get 1.0 times 10 to the minus 6 meters per second. And this is the same as 105 feet per year. So the 2 sig figs. So one of the last things that I want to do in this chapter here is that I want to give you a sense of some of the questions that you're going to have to come up with some of the data on your homework. Like one of your homework questions says, estimate how fast your hair grows. Well, of course, on a daily basis, you can't estimate how fast your hair grows. You have to wait a week or 2 weeks or guess how long, in between haircuts, how long your hair has grown. As an example of this, I'm going to say here is that some homework problems will ask you to estimate certain speeds, like how fast does your hair grow? And to give you a sense of how you need to answer this, I have this final example that I want to do. Again, let me make this a little bit bigger and distort the image. And it's still the same kind of question that we've been dealing with. It's still a conversion factor. And there's no hard answer. I could give you an approximation, but it's all an approximation here. So it says here in example 1.4, it says, blades of grass grow from the bottom. So as growth occurs, the top of the blade moves upward. During the summer, when your lawn is growing quickly, estimate this speed in meters per second. Explain how you made this estimate and express your result in scientific notation. So let's look at this thing here. Well, the way I would look at this thing here, so if I was to try to write a solution here, the first thing I must do is estimate the growth of the grass. I can't sit there and watch the grass grow. However, if I cut my grass, let's say once a week, and it's grown 2 inches, so then we could then say that by observation, I'm going to say that it grows 2 inches per week. So now I have a conversion factor. So then that means here is that my speed of how fast the grass grows is then going to be 2 inches in 1 week. So now I start my process of conversion. Okay. And it goes something like this here. So let's say that I start with my, I don't know, let's start with my my distance here. So I'm going to focus on inches. So if I focus on inches, I'm going to say that I know that 1 inch is the same as 2.54 centimeters. And I know that there are 100 centimeters in 1 meter. So right away, what I've done here is that I've dealt with the distances. So I'm at 1 meter. So my units have now been converted to meters. So here, all I did here was I focused on distance. Now I'm going to focus on time. So when I look at my time, I'm going to convert to days. And then I'm going to convert to hours. And then I'll convert to seconds. So then if I look at this thing here, now I'm going to focus on a week. So I know that 1 week is the same as 7 days. And I know that 1 day is the same as 24 hours. And I know that 1 hour is the same as 3,600 seconds. So you could see here is that now, if I look at my cancellations, I've canceled out my weeks, I've canceled out days, I've canceled out hours, so I'm left with seconds in the denominator. So then here is my time. So now if I convert this into units of, they want it in scientific units, I'm going to get to 2 sig figs. I'm going to get 4.2 times 10 to the minus 8 meters per second. And this is how fast the grass grows. So this is the end of chapter 1. Okay, and so when we look at the quiz on Thursday, you're going to get 2 questions. One question will be on a motion diagram, very similar to what we did here. And one question is going to be on a conversion factor.